Hello everyone, I'm Aditya and I'm your TA for the deep learning course this fall, and welcome to this recitation on Google Colab. So what is Google Colab? Google Colab is a Jupyter Notebook style Python 3 execution environment which can be accessed from your browser without any setup. It is provided by Google Research as a free tool. So to use Google Colab, you need to create a notebook, which you can do from this link. So from here you can create a new notebook, which will be a blank notebook that you can rename, and it will be saved in the Google Drive of the account used to create the notebook. Alternatively, you can also load notebooks that you have already created. So if you have any notebooks that you are working on, then they will show up in this list. And you can even upload notebooks from your computer. So as we can see, Colab has an intuitive interface, and we can create code cells or markdown cells, which are very helpful to structure different parts of your code. So once you have a notebook open, the next step is to set up the processor and the runtime environment. So why we recommend Google Colab is because it provides free access to GPU. So we can go to runtime type, and we can select either GPU or TPU. And we will be using GPUs throughout this course for training our models. Also, if you are a Colab Pro subscriber, then you can get access to high RAM environment, which is basically a better version of a CPU. So that can speed up your data loaders and any pre-processing code that you may have. In the context of this course, it is not needed, and in my experience, it did not make a difference in the data loading steps. So a tip would be that if you do subscribe to Colab Pro, then running a notebook in high RAM will prevent you from operating multiple notebooks with GPUs due to Colab limits. So if you want to train multiple models side by side, then do not use it. So Google Colab runs on a Linux environment, and you can interact with the terminal using the exclamation operator. So you can execute any bash command and even install particular libraries that you may need. So here we install Torch, which is already present, so it says requirement is satisfied. And we can also use the NVIDIA SMI command to see which GPU we have been allotted, and this is something that's good to know. So the free version of Colab mostly provides a Tesla K80 GPU, and if you're lucky, you may get a Tesla T4 or a P100. So we can also connect Google Colab to our Google Drives using the drive.mount command, and it will then ask you for permission to your account. So once that's done, you can access your drive at this location, and this will mount the drive of the same account that is being used for code execution. And there are workarounds for connecting to drives of other accounts, but it is not supported by Google anymore. So once your drive is connected, you can use it as any standard storage space. You can then interact with it through the OS module or through terminal. And here we create a directory named IDL Fall 2022 Colab tutorial and list its files, which are currently empty. So next, once we have a directory, we can write files to it and load files from it. So let's start by saving a pandas data frame. So here we create a pandas data frame from a dictionary, and we will save it as a CSV file to the folder we created. And we can list the updated contents, and we see that our file has been saved in the directory. So now we can read it, and while reading it, we specify the column we want to treat as index. Here I use column 1 as the index, so we can see that our data frame is indexed on column 1. And not just CSV files, we can also save PyTorch models as serialized objects. So here we have a very simple neural network. And the process of saving is pretty much the same. We can specify a path with the same prefix and a name to our model file. And then we can use the inbuilt torch.save command directly with the assigned path. So here we save our model with some additional information, and we can see that the directory we created has our model file. And we want to save our models to the drive, which is persistent storage, because files saved to the contents folder will be lost once the runtime is reset, so be careful about that. So we can also use the same path to load the model as well. And saving models will be very useful when you are running long training jobs, and it is good practice to checkpoint your models every few epochs so that you can load the best one when you want to make the submission, or maybe for even if you want to train a model further with different hyperparameters. So the homework assignments for this course consist of Kaggle competitions, and luckily we can connect to Kaggle directly from Google Colab. So to do that, you will need your Kaggle token, and to get it, you can go to Kaggle, go to your profile, go to the accounts tab, and in the API section, there is a create new API token option. If you click this, you will download a JSON file, which will be a pair of key values. And this will be your username and the key, which you can just copy paste here to connect to Kaggle. And so these are the steps that you will have to execute to set up Kaggle for Google Colab. So this notebook is linked in the description, and you can directly paste these commands when you have to use them. So we see that Kaggle has been successfully set up, and now we can use the Kaggle commands to get the data or make a submission to a competition. So for this tutorial, we have a dummy competition here, and we can download the data directly with a Kaggle command. So for each competition, you will find the command under the data tab on Kaggle to download the data. And you can just directly copy paste this into Colab with an exclamation operator and execute it. Next, you will unzip the data. So now if you go to the file explorer on the left, then you can see the data that you have downloaded and unzipped, which is the sample submission.csv and train.csv file. So also, once you have a model working and you have created your submission file for the competition, you can also directly submit it from Colab. And for that, you can use the submit Kaggle command. So for that, you can navigate to the submissions tab on the competitions page, and there you will find the Kaggle command to submit to that competition, and you can add any message that you want, and then you can execute the cell, and it will directly submit the file to Kaggle. So now we can see that the file we just submitted from Colab is successfully submitted to the competition. So another useful tool is the variable inspector. So just above the file inspector, we will see the variable inspector. And this will basically show you a summary of what different variables you have and what they contain. So here we can see the type and the shape of our variables. And this is helpful for keeping track when you are training a model and you have a lot of data loaders and variables that you want to keep track of. So finally, now resetting the runtime. So one of the most common errors that students encounter in this course is the GPU running out of memory, or the GPU running into other weird errors. And in that case, you will have to restart the runtime. So basically flush the GPU, and then you can rerun your code. For that, you have a couple of options. So If you choose the restart runtime option, then this won't delete the files you have downloaded or uninstall any libraries that you have custom installed. However, if you do the factory reset runtime, it will delete all the files and any custom installations that you have made onto this environment. So finally, now Google comes with a free tier. There is no subscription required. As long as you have a Google account, you can access the free tier of Google Colab readily. It also has a pro version, which I strongly recommend. It is $10 a month and it has faster GPUs, more memory, and longer runtimes. So if we scroll down, we can see the differences. And with Pro, we get up to 24 hours of persistent connections, whereas with the free version, it is just 12 hours. And we also get better GPUs with Colab Pro, so you will most likely get a P100 GPU, which you may or may not get with the free tier. So while I do recommend Colab Pro, but the free tier is enough for all the assignments throughout this course. And if you start well in time, then you can get by with just the free tier. So that was it for this recitation. And if you have any questions, then you can obviously get in touch with me or any other TA, and we will try our best to help you out. Thank you.